Well, we've reached the last video on these FRQs, and this one is called Other Topics. Now, generally, these other topics show in as parts of FRQs. Now, the first common topic that's other than the other six is implicit differentiation. Wow, if you get one of these problems, you will be shouting hallelujah, because this is where you basically have to given a function and take the derivative a couple times. Now, generally, it's first and second derivative of an implicitly defined function, and then you'll be asked probably to find an extreme, set the derivative equal to 0, or you may be asked about concavity, that's the second derivative, or where is the tangent, horizontal or vertical. So that'd be the derivative of the numerator equal to 0, or the derivative of the denominator equal to 0. Now, what do you need to be able to do? Is find the first and second derivative, or you're given the first derivative, find the second derivative, and make sure you substitute the first once you've taken it implicitly. As I just said, horizontal or vertical asymptotes, the numerator equal to 0 is horizontal, denominator equal to 0 is vertical, and set the derivative equal to 0 and find any max or mins. So, the second part of an other topic is related rates. Now, generally, a related rates is not an entire FRQ, but just a portion. Now, don't freak out about related rates. Remember the process for related rates. The first thing you do is you determine what is the equation. Now, generally, related rates will either be Pythagorean theorem, or related rates might be area or volume, so like maybe a cylinder, pi r squared h. Or it could also be an angle. You have to find the change of an angle. Tangent theta is y over x. And so what you do with these, first of all, decide the equation, and then are there any values that are constant? If so, plug those in before you take the derivative. So if I'm doing a Pythagorean theorem and the ladder length is constant, I'd have x squared plus y squared, and maybe the ladder length is 12 feet, so 12 squared. Now I take the derivative in respect to time. So this is where we get implicit differentiation. So we have 2x dx dt plus 2y dy dt equals 0. You get the mode. And then you substitute in all of the conditional values. Answer the question in context of the problem. Use your units to analyze your solution. Not so bad, you guys got those related rates. Okay, here's your first example. This is a nice implicit differentiation. Make sure you answer A through C using a pencil. This is no calculator, and then we'll correct it in pen. Did you like this problem? I thought you might. So first thing you do is write an equation of a tangent line. Woohoo! Slope and point, baby. So you plug in the point to get the slope. It's 1/4. And then you use that point to write your equation. And of course it's correct if you wrote y minus 1 equals 1/4 x plus 1. Next, you have to find the coordinates for where the line is vertical. That means we look at the denominator. So we set the denominator equal to 0. And now we solve for x. X is the easiest variable to solve for. So x equals 3y squared. And we're going to plug that value back into the original function. So now we have y cubed is equal minus xy equals 2. And so we're going to substitute x with 3y squared. So now we have y cubed is 3y squared times y equal 2. Solve for y, and the y value is negative 1. Well, we needed to know the x value. We needed to know the coordinates. So I put negative 1 into the function for y, and I solve for x, and I get 3. So the point is 3, negative 1. Okay, last of all, part C, you are asked to find the second derivative. So you take the derivative of the first, and it's a little quotient rule, low d high minus high d low. Now they're checking to make sure that when you take the derivative, you're using your implicit differentiation correctly. And so we get some dy dx's here. So we replace dy dx with the derivative, and it's at the value negative 1, 1. So we find those values, plug it in, and we get the answer 1/32. Now, I hope you racked up points on this question. Did you score above a 7 on this, a 7 or higher? I really hope so. If you made any mistakes, what were those mistakes, or what were your misunderstandings? Okay, our last other example, and our last FRQ completely for this review. So we are looking at, this is allowed for a calculator, so we've got oil leaking from a pipeline. Okay, we've got a surface of a lake, and forms an oil slick whose volume increases at a constant rate. Ooh, do you see how it's centimeters per minute? So that's a rate. The oil slick takes the form of right circular cylinder. Ooh, we know cylinders, right? It looks something like this. Okay, and we are told that both its radius and height are changing. Ooh, that's nice. They give us actually the volume formula for the cylinder, but you should know that. Pi r squared times the height. Okay, now we've got all the facts. Now you're going to have to answer some questions. Answer all 3 parts. Don't give up on any. Show work. Give me something for all in pencil, and then we'll correct it. So did you recognize part A to be a related rates question? I hope you did. And it wasn't too bad, actually, because you were given the formula, volume equals pi r squared h, and you had to ask yourself if anything was constant first. No, nothing was constant. So what you had to do is you had to take the derivative in respect to time. So you did have to do a little product rule here. So you did 2 pi r, and then derivative of r is dr dt, h stays the same, plus, now you have pi r squared, and then you take the derivative of h over t. Now just substitute in all those values they gave you. And so they gave you a lot here, and you can use your calculator now to solve for dh dt. And so notice this was worth 4 points. That's a lot. So were you able to get these correct answers? I hope so. It was really important to get those 4. Okay, for part B now. So now you're given another function. You're given r of t, and this is the removal of oil. Okay, so this looks a little bit like an accumulated rate problem, right? So you're told the removal is 400 radical t. Okay, and so that's your derivative of volume, and now, no, that's the removal. Now we know that we're putting oil on there at 2,000. So the rate of change in the volume is going to be adding 2,000, taking away 400 radical t. Okay, and so we need to find, what are we looking for here? We're maximum volume, so we must set the derivative equal to 0. So we do that, and we find that it occurs then at 25 minutes. Okay, and so now you have to decide whether this is a maximum or minimum. So you look at the function from the left and to the right and see what the sign is changing from. So because it is greater, it changes from positive to negative, we know we have a maximum volume. 1 point for justification, 1 point for the answer, and 1 point for finding r of t is equal to 2,000. And the last question then is you're given initial value now on this. You start off with 60,000 cubics. So here's your initial value, and we want to find the amount of oil. So we take the integral from 0 to 25 of the rate of change, which we figured out previously was 2,000 minus 400 rad t. Now you get 1 point if you at least got the limits and initial condition, and then another point for the integrand. So how'd you do on this one? I threw a related rates problem with some fundamental theorem and all kinds of stuff. What was your score on this second FRQ? And what were your weaknesses and any mistakes that you made on that? Congratulations, you're done with your FRQ review.